In the vast expanse of the universe, where stars ignite, planets migrate, and galaxies collide, there are moments when something unexpected crosses our path. These moments remind us that the cosmos is far from static. It is a living, dynamic stage, filled with objects that travel for millions or even billions of years before their presence is noticed by civilizations like ours. Among these rare wanderers, a new visitor captured global attention: 3IATLAS, the third confirmed interstellar object to pass through our solar system. Neither a spacecraft nor an anomaly, but a true cosmic traveler that originated from a distant star system. This documentary explores the full story behind 3IATLAS, how it was observed, how its nature was confirmed, and why its passage represents a remarkable scientific opportunity. Using images from multiple NASA missions, measurements from the Indian Space Research Organization, and data collected across several points in the solar system, we assemble a clear and coherent picture of this extraordinary object. To understand 3I Atlas, we must first recognize what an interstellar object truly represents. Unlike the asteroids and comets that reside within our own solar system, bodies that were formed alongside the Sun, interstellar objects originate from planetary systems light years away. They are fragments ejected during the early stages of planetary formation, or remnants from catastrophic gravitational encounters. Once expelled, they drift through the void between stars, traveling for immense spans of time before intersecting another solar system. 3IATLAS is one of these fragments. Before arriving here, it likely orbited a completely different star, within a disk of ice, gas, and rock. Some gravitational encounter long ago accelerated it enough to escape its home, sending it on a trajectory that eventually crossed our own solar system. Once discovered, the object immediately sparked curiosity. Early brightness variations and its high velocity raised questions about its composition and type. Was it a comet, an asteroid, something entirely new? As with every rare cosmic visitor, speculation flourished, but speculation alone is never enough. What followed was a global scientific effort to gather data from every instrument capable of observing the object. And as the observations accumulated, the truth became clearer. 3I Atlas is a fully active interstellar comet. The turning point for understanding 3IATLAS came on October 3, 2025, when the object passed approximately 30 million kilometers from Mars. For interplanetary distances, this was a relatively close encounter. Several spacecraft orbiting Mars, and even a rover on its surface, were in a prime position to observe it. The Mars Reconnaissance Orbiter and the HiRISE camera. On October 2nd, the Mars Reconnaissance Orbiter, MRO, using its HiRISE camera, captured what became the most detailed image of 3I Atlas ever taken. The photograph revealed a well-developed coma, the cloud of dust and gas that surrounds the nucleus of an active comet. Its structure was unmistakably cometary, a concentrated central region, surrounded by a diffuse halo of illuminated dust particles. The HiRISE image alone did not answer every question, but it provided the clearest visual evidence that the object was not an asteroid and certainly not an artificial craft. It behaved exactly like a comet warming up as it approached the Sun, MAVEN detecting hydrogen in space. While MRO provided visual confirmation, the MAVEN mission contributed chemical evidence. Designed to study the escape of gases from the Martian atmosphere, MAVEN detected three distinct forms of hydrogen: hydrogen coming from Mars, hydrogen from the interplanetary medium, and hydrogen released by 3I Atlas. This was a crucial discovery. Hydrogen emission is common in comets because many of their ices contain water and carbon compounds that break apart when heated by solar radiation. MAVEN's ability to isolate the comet as hydrogen signature proved that 3I Atlas was releasing gas, a defining trait of active comets. Perseverance, an observation from the Martian surface. The Perseverance rover also captured a faint but meaningful image. Against the dark Martian sky, a barely perceptible point of light traced its slow passage. Even though subtle, this observation symbolized something remarkable: a robot standing on another planet witnessing the arrival of a visitor from another solar system. It was a reminder of how far our exploration has come and how interconnected modern missions have become. While Mars provided an excellent vantage point, several spacecraft orbiting the Sun also recorded the comet. These missions offered different angles, distances, and instrumental perspectives that enriched the global dataset. SOHO, a seasoned comet hunter, the Solar and Heliospheric Observatory SOHO, famous for discovering thousands of comets during its operation, detected 3IATLAS between October 15th and 16th. The images revealed the same familiar features: a bright coma, a diffuse shape, and motion consistent with cometary dynamics. SOHO's observations helped confirm that the comet remained active even as it moved farther from Mars. Punch monitoring the heliosphere. The Punch mission captured 3IATLAS between September 20th and October 3rd, even at a distance of 370 million kilometers from Earth. The comet's coma was discernible. These images were important because they highlighted how the dust cloud behaved in relation to the solar wind, a factor that influences the formation of comet tails. Stereo, a three-dimensional perspective. The stereo mission, which consists of two spacecraft positioned at different angles around the Sun, provided stereo images that helped refine the comet's trajectory. By observing the same object from two separated points in space, scientists were able to track subtle changes in its motion and assess how radiation pressure was shaping its coma and tail. Beyond the missions orbiting Mars and the Sun, two spacecraft traveling toward asteroids also crossed visual paths with 3IATLA's Psyche images from September. NASA's Psyche mission captured the comet on September 8th and 9th in both images. The coma was clear and bright enough to measure, confirming once again the consistency of cometary activity during that period. Lucy detecting the emerging tail. The Lucy mission, journeying toward Jupiter's Trojan asteroids, recorded a series of images in which a subtle tail began to emerge. Although faint, this tail indicated the direction of gas and dust being released from the nucleus. Its presence added yet another layer of confirmation. 3IATLAS was behaving exactly as a comet should. While spacecraft gathered visual and positional information, one of the most scientifically decisive contributions came from Earth at the Mount Abu Observatory. The Indian Space Research Organization obtained a detailed spectrum of 3IATLAS using a 1.2-meter telescope. The spectroscopic data revealed unmistakable signatures of C2 diatomic carbon, C3 and CNC. These molecules are classics in cometary chemistry. Their detection indicated that the gases released from 3I Atlas are consistent with the composition of comets found within our solar system. Even more striking was the measured production rate, around 10 molecules per second, which is entirely within the range of typical cometary activity. With this evidence, the debate was effectively settled. 31ATLAS is a comet, a truly interstellar comet exhibiting both familiar behaviors and unique traits born from an origin in another star system. Some observers noted differences between 3I Atlas and comets native to our solar system, but such differences are not only expected, they are scientifically valuable. Comets serve as time capsules. Their composition preserves the conditions of the stellar nursery in which they formed. Since 3IATLAS originated in a different system, its chemistry naturally reflects a different environment. To understand this, one might imagine a simple analogy. Rice prepared in different regions of Earth may have distinct flavors, textures, or ingredients, yet it remains rice. Likewise, an interstellar comet may vary in composition without losing its cometary identity. These differences help scientists map the diversity of planetary systems across the galaxy. The closest approach of 3IATLAS to Earth will occur on December 19, 2025, at a distance of about 270 million kilometers, nearly twice the distance between Earth and the Sun. It is far, but still close enough for ongoing monitoring. NASA has confirmed that more images from the MROS HiRISE camera will be downloaded in the coming weeks. Other spacecraft will continue to track the object as long as it remains visible. But eventually, the comet will fade from sight and resume its solitary journey through interstellar space, likely never to return. This moment is fleeting. Every observation made now is unique. Humanity will not receive a second opportunity to study this object. Throughout the period of observation, misinformation spread rapidly, fueled by speculation detached from scientific evidence. Some claimed that 3I Atlas was an artificial craft. Others insisted that agencies were hiding the truth. Such claims dissolve when faced with actual data. The case of 3IATLAS demonstrates the value of evidence-based science. Data analyzed by independent teams across multiple continents converged on a single conclusion. No extraordinary explanations were required, only careful observation, collaboration, and scientific discipline. The passage of 3IATLAS is not merely an astronomical event. It is a reminder that we are part of a much larger universe, filled with worlds and systems we may never see directly. Yet occasionally, fragments of those distant realms pass by, offering us a glimpse of their history. This interstellar comet is a messenger. Its chemistry, motion, and activity carry information about the environment in which it formed, a place far removed from our solar system. By studying it, we expand our understanding not only of alien comets, but of the diversity of planetary systems across the galaxy. The story of 3IATLAS is ultimately a story about curiosity, collaboration, and the relentless human desire to understand the unknown. And as it continues its silent journey back into the darkness between stars, it leaves behind a legacy of discovery that will be studied for generations.